learners. In the previous video, we have seen NumPy image processing and how to read an image and how to display it, how to know the basic information of the image like size, dimensions, and so forth. And how we have already seen how to resize that image into a smaller pixel size and still retrieve most of the information, and how to crop the necessary part of the image we have completed so far. So from now, we are going to do some techniques, some filtering or some pre-processing in which you can create more images like the same. So first, we are going to see rotation. So when you want to create similar more images, we can use some effects. We can apply from effects and convert it into a different image. So the machine will understand that it is just a different image. So it would be better in predicting this as well, no matter how different the image looks. So rotation, we'll first see how to rotate the image. So to rotate the image 4. I have used up to image 3 variable. I'm using image 4. In this, we are going to see np dot rotate 90. Yes, rotate 90. I'm gonna use 2. plt dot im show image 4. So this is my original image. I think this is in 2. Yes, this is the original resized image, and that is being transposed, rotated 90-degree. So this, by the computer, this recognize this 90-degree rotated image as a different image, so that you will have more images for training. During training phase, you will have more images. And during testing, no matter how the dog or how a object looks, the machine will be able to predict the image correctly. So this is why we use np.rotation, rotation 90-degree. So let's go for the next one. We have done rotation. Let's do flipping. So in flipping, we have two type of flipping. One is up and down, and the second is left and right. So up and down shift, we'll see that first. So for that, I'm going to use image 5 np dot. I have flip function, flip ud, which is flip up and down. So in that, I'm going to give image to plt dot im show image 5. So this is up and down flip. So whereas if I want right to left to right flip, that is the mirror image of whichever image we are giving. So LR, I'm gonna use 6. This is the mirror image of the image we have seen earlier. So this is the actual image, and we have been seeing the mirror image. This is the mirror image. So if you want to convert the image into a mirror image, you can use flip LR. And the next thing we'll go for is separating the channel. We'll be separating the channel or extracting the channel. Extracting the channels. Extracting the channel is nothing but we have this image in a format of RGB, red, green, and blue. What I'm going to do is I'm going to segment red, green, and blue separately. That is what I'm talking about. So let's say I'm going to work with image 2. This is my image. So I'm going to segment only the red from these, only the green from these, and only the blue from this. So let's say I'm gonna use only the index 0 of 0. So it will be easier. So here I'm going to segment RGB from this. So let's see. So usually while gathering, we'll be doing BGR, not RGB, BGR. So it will be in a reverse. So the first channel is going to be BGR. So for B, I'm taking rows and columns, everything, but only on the third index, I'm only taking 0. And IMG2, colon, and 1. Since this is a 3D imaging, 3D array, I'm doing like this. I'm taking entire row, entire column. In third dimension, I'm taking only 2, only a particular dimension. So that is run. So I'm going to use the same to visualize in here. Instead of this, I'm going to use B. As you can see, B is 72. And I'm going to do the same. And this is going to be G. And this is going to be R. Oh, I've given 3 here. Sorry, it's 2. Yes. As you can see here, the first number is taken as blue, the second number is taken as green, and the third number is taken as red. This has been showed here as well. For B of 0, 0, I'm getting 72. For G of 0, 0, I'm getting 67. For R of 0, 0, I'm getting 50. This is how we extract only the separate channels from this. If you want to visualize this correctly, by doing IM show will not be able to visualize this properly, since all of the images, no matter how much I change this, all of the images will look something kind of greenish, because that is how the default settings have been given. So everything will look kind of greenish. Will not be able to see any much difference here. So to see the difference properly, you just have to specify the color map. Color map, I'm first gonna say blues. Blues will give me only the blues. And let me see the color map here, which is greens. It only shows the green channel. And here I'm seeing the color map red. For that, I'm gonna use reds. So that is reds. So you can use these color channels to actually visualize these images correctly. Instead of color channels, every other images looks exactly the same. To prevent that, use the color maps. So for blues, I have used blues. For greens, I'm using green. And for red, I'm using reds. So it is segmenting the colors properly. So finally, let's say you're converting the color image to grayscale image. Grayscale is nothing but a black and white image. Grayscale is nothing but a black and white image. So let's say I'm gonna convert this image, the image to, I'm gonna convert this image into a RGB image. Sorry, a grayscale image. For that, we need a specific formula, 2989 multiplied by R. This is actually a universal formula to convert anything into any image into grayscale. G plus 0.140 multiplied by B. plt.im show IM gray, comma, and CMAP has to be given as gray here, since that is the correct one. So here is the gray. So the black and white image. From the RGB image, we have converted the image into black and white. This is the standard formula to convert any RGB image into a grayscale image. This is the ratio which cannot be changed. So thank you so much. We'll see in the next video.